Good morning. Hope you're having a good day today. Please notice the lesson plans on the sideboard really quickly. Those are going to be the lesson plans for the next 2 days. Okay? Same lesson plans, same homework. So when you get to class, the next time I see you, am I going to be checking those exact problems at the bottom? No. Okay? It'll be 2 class periods before I check that homework. Okay? We're going to spend 2 different days on all of this stuff because there's a lot of stuff in one section. Okay? It's not that it's hard, it's that there's a lot of it, and I want to take some time on it. Okay? Quadratics are kind of an integral, basic part of Algebra 2. We want to make sure we're good at them. Fair enough? Okay? So I have 2 equations written for you up here. Both of these equations are quadratics. How could you tell that they are quadratics? What makes something a quadratic? Squared. Okay? If it's squared, that means it's a quadratic. So both of these are quadratics. So I want you to know the difference between these. You need to know, first of all, you need to know both equations, and then you need to know the difference in between them. Fair enough? First equation. It's called standard form. That's the standard form of a quadratic. That tells us a lot of good information, depending on what we're doing. Okay? The second equation right here is called vertex form. It also tells us a lot of good information, depending on what we're doing. We might choose one of these over another when we're doing something specific because it seems to tell, one of them seems to tell us more than the other. Okay? Now, if you'll remember, we've actually already talked about this. We talked about it first 6 weeks because we talked about transformations. Remember that? Transformations? Which way, what kind of shift does this H cause? Horizontal, right? Horizontal shift. What kind of shift does this K cause? Vertical, right? Vertical. Okay. Now the vertical shift moves exactly where you think it should, right? If it's +2, where's it going to go? Up 2, right? If it's -3, where's it going to go? Down 3. What about when it's inside? What do you remember about that? If it says x -3, which way is it going to go? To the right 3. Okay, remember, because this minus is part of the equation, when we have to solve for h, it's going to give us a -3. Okay, what if it said x +1? Which direction would it go? Left 1. Okay, now what does the a do? Yeah, this is what they're doing. It changes the steepness or the shallowness, right, of the parabola. Okay? Now, are these 2 A's exactly the same? Probably not, right? They're in 2 different equations, and they are the same letter, but we need to keep them separate in our mind. Okay? So, first thing I want to show you, actually, though, is in your book. Okay? On page 108, would you turn to please turn to page 108 in your book? I want you to have this to refer to as we're going through it. Okay? I don't know what it is about this section, but this section has some amazing examples and some amazing core concept explanations. Okay? A lot of the book has really good examples, really good core concept explanations, but this section is really, really good. Okay? Excuse me, page 108. Okay? Page 108. Starting at page 108, I guess I should say. Okay? This section has some really, really good examples. So, do you think I'm going to have you write down every single one of these good examples that you already have in your book? We already have them, right? Now, we're going to write down some others because we know, because of learning strategies, that if you write it down, you're more likely to remember it, right? So, we're going to be writing stuff down. That's why we have our notes out. Okay? But look here, the very first thing that's highlighted in your book, it says Axis of Symmetry. Have you ever heard of an axis of symmetry before? Have you heard of a line of symmetry? Oh, yes, you have, right? Okay. So would it make sense that we could use the word axis of symmetry in a problem that has a parabola? How many lines of symmetry does a parabola have? Just one. That's exactly right. Okay. And if it just has one, we're going to give that a name and we're going to call it an axis. It's an axis of symmetry. Okay. It does everything a line of symmetry does, but at least this book chooses to call it an axis of symmetry. Sometimes, guess what? Sometimes we are allowed to call it a line of symmetry, and that is okay. All right? So it says it's a line that divides a parabola into what? What's it say? Okay. And passes through the vertex. So mirror images, does that fit with what you know about symmetry already? Okay, good. So then it gives you a formula. How do I feel about formulas? Yeah, I don't like them. I'd rather us know the concept, right? Now, some formulas are necessary. I get it. I promise I do. But if we understand what's happening in this line of symmetry, we can know it. We don't have to memorize a formula. Fair enough? So let's look at this graph real quick. I'm going to zoom in on it so we can look at it a little easier. Okay? We're looking right here at this graph. Okay? We know that the vertex is at HK. Wait, do we know that? Do you remember that from transformations? Okay, in case you don't remember that, our vertex is at HK. Always? Always. Okay, for a parabola, our vertex is at HK. So if I have what kind of line is this? Oh, a vertical line that passes through HK. Where is it going to cross the x-axis? At H, right? Does that make sense? That's how far we went over. Then we went up k value, but that's how far we went over to get to our vertex. Okay? Whoa, wrong way. So if you're asked for the line of symmetry, or axis of symmetry, as long as we know the vertex, we know it's going to be x equals h. Now, I know some of you are thinking about, well, is it going to ever go sideways like this? Our parabolas can go this way, can't they? Yes, they can. Why are we not looking at those right now? Parabolas that go this way are not functions. And all that we're doing right now in Algebra 2 is studies of functions. Okay? We don't get to studies of non-functions until later. So right now, all we're doing is studies of functions. So all we're going to talk about are parabolas that open up or down. Fair enough? We'll get to the other stuff later. Don't worry. Don't worry. Don't. Okay? So, any questions about finding an axis of symmetry? Okay? So here's an example. Identify the what? Constraints. Okay? Identify the constraints. Oh, constants. Is that what you're saying? Let's look at it closer. Oh, yeah, constants. Okay? So it says graph this function, label the vertex and axis of symmetry. Well, if it's in vertex form, don't we know the vertex? -3, 4? Everybody okay with that? -3, 4? So if that's the vertex, I can go plot on a graph -3, 4. Now, what do we know about the negative in the front? What does that cause? It causes it to open down, right? It causes the parabola to open upside down, like this one right here. Well, this is the graph. It's the answer, but you know what I'm saying, okay? What does the 2 cause? Causes a vertical stretch. Remember that from transformations? I know it's been a while. It's okay. All right? So the negative reflects it across the x-axis. That's the right math vocabulary that we need to be using. And then the 2 stretches it. Okay? And our vertex is at -3, 4. Why is it -3? Why isn't it just 3? Because it's x minus h, right? We have to solve for h. So h would be a -3. Okay? So step 1, identify the constants. I don't know why I couldn't read that word earlier. Sorry about that. Plot the vertex, hk, just like that. And then draw the axis of symmetry. Is it important to know the axis of symmetry? Yes, because you know it's mirrored on each side of the axis of symmetry. And then plug in points. Choose some points. Put in, if you know this is the axis of symmetry, figure out where it is at 2. Negative 2, excuse me. Plug negative 2 into this equation, right? Now, this is all nice and good if you don't have a calculator, but we have calculators, okay? So can't we put this equation into our y equals, our f of 1, and go look at the table? We plot those points that are given to us on the table that are on our graph. And then our last step, draw the parabola. Well, if you have all the points plotted already, is that a hard thing to do? No. Okay? Any questions? So, are you okay with a line or axis of symmetry? Are you okay with being able to graph from vertex form? Yes? Okay, look at standard form then. It's at the bottom of that page. Standard form. Quadratic functions can also be written in standard form. Remember, I already showed you that. Okay? Oh, why do they have to say a is not 0? What if a was 0? What kind of equation would that be? Well, it would be a line, wouldn't it? Almost like mx plus b, just different letters there, right? So a has to have a value that's not 0 so that it can be a parabola. Okay? So they're showing you right here through these steps that you can actually get to standard form by starting with vertex form. Okay? I'm not going to do that for you because it's already right here. Okay? If you square that, x minus h times x minus h, you would get x squared minus 2hx plus h squared, multiplying that by a, and then plus k. If you distribute your a throughout everything, you get ax squared, and then you have negative 2ah, and they're going to call that b. And then you get ah squared plus k. Again, those are all constants, and so we're going to call that c. Do you see where the standard form is gotten from the vertex form? Am I going to make you do this on a test? No, but could you do it if I ask you to? Hopefully, okay? So a has the same meaning in the vertex form and standard form. Remember how a second ago I said, are these exactly the same letters? They mean exactly the same? You never ever want to assume that, okay? But now they're telling you right here in black and red and white, right, that they have the same meaning. So is that good? Yeah, we don't have to memorize a whole bunch of new things, right? B, oh, this is nice. To solve for h, you can have negative b over 2a. Well, that's nice. We'll use that later on. Axis of symmetry, negative b over 2a. Okay? Probably, but let's go ahead and write that down. Okay? Let's write a couple things down while we're here on our notes about vertex form and standard form. Where's the vertex? You remember that? Where's the vertex? HK, right? And where's the line of symmetry? Is it okay if I write L of S? Does that mean anything bad? Okay, L of S, line of symmetry. Where's the line of symmetry if we're talking about vertex form? Refer back to your book if you want to. X equals H. So looking at standard form, where did they say the line of symmetry is? X equals negative b over 2a. Any questions about that so far? So we've got two forms. We've got standard form and vertex form. If we're in standard form, we're going to find the line of symmetry by saying x equals negative b over 2a. Okay? If we have vertex form, we know the vertex is at hk, and we can find the line of symmetry by saying x equals h. Do we know the vertex for standard form yet? No, not yet. Okay, so we're going to write it down when we get to it, so we're not there yet, so we're not going to write it down. Okay? Any questions so far? Okay, I'm going to get the book back up here. Let's look at this core concept on the top of this page. Okay, on the top of page 109. So what form is this? Standard form, okay. So, what is this? It's on both graphs. 0C, 0C. What is that? That's where it's crossing the y-axis, isn't it? What's that called? The y-intercept. That's exactly right. Okay? Where the parabola crosses the y-axis is the y-intercept. 0c. So it tells you right in the equation where the y-intercept is when you're in standard form. Is that true? It sure is. Okay? So let's go back to our notes. Whoops. Oh yeah, that's right. So the y-intercept looks like 0c. Why is it 0c and not c0 or something like that? Yeah, this is a y-intercept. X is always 0 on a y-intercept, isn't it? Good. So if I was trying to find a vertex, would it be easier to use standard form or vertex form? Vertex form. If I was trying to find a y-intercept, which one would be easier to use? Did I say anything about the fact that k is the y-intercept? That's because it's not. Okay? You can't just assume that this number right here is the y-intercept in vertex form. In standard form, however, it's right there, right in the equation. You can see the y-intercept. Okay so far? Okay. On that page, there's an example number 2. Okay? Example number 2 says graphing a quadratic function in standard form. Okay? So same kind of thing. On the previous page, we did an example where we were graphing a quadratic function using vertex form. Now we're graphing one using standard form. Okay? So first of all, we want to identify the coefficients a, b, and c. Well, how can I identify those in standard form? Boom, boom, boom. Drop the mic. Okay? They're right there. They're given to you right into the equation. Okay? A, B, and C. Well, why is it important to know A, B, and C? Well, to find the vertex... Oh, they talked about that up here. I skipped that. I'm sorry. Up here in this top box, it talks about axis of symmetry. It talks about how it's opening up. It talks about the y-intercept. But does it make sense to you that if the axis of symmetry is x equals negative b over 2a, then that would be part of the vertex also? Yeah? Okay, well, let's go and write that down before we go on. The vertex here with standard form is negative b over 2a. And then this is what they have written. F of negative b over 2a. What the heck does that mean? Oh, yeah. We take what we know for x and plug it into the equation, into the function, and get a value. We evaluate the function at that value. Yes or no? Okay. Let me get the book back up here then. So negative b over 2a gives us the x-coordinate of the vertex. Once I know the x-coordinate of the vertex, I take this, in this particular case, a 1, and I go back up to the equation, and I plug in a 1 everywhere there is an x. That's exactly right. What's 1 squared? 1 times 3? 3. What's 6 times 1? 6. So I have 3 minus 6, negative 3, plus 1. Oh, look, negative 2, exactly what they got. Okay, so my vertex is at 1, negative 2. Can you plot the point 1, negative 2? Yeah, we've been doing that for, what, since 4th grade, 5th grade, something like that. Okay, we draw the axis of symmetry in. Okay, now a lot of times, it's not true in this book, but a lot of the material I've seen in my 18,000 years of teaching, the axis of symmetry is a dotted line. Because it's not really there, it's just kind of a guide for us. Okay? So if you want to draw it a solid line, that's fine. If you want, probably when I draw it for you, on any examples I do, I'm going to draw it as a dotted line. Okay? So we draw our axis of symmetry, then identify everything that we know. For instance, the y-intercept. Well, if we look up here into the equation, what's the y-intercept? 1. Wait, the y-intercept is 1? Or is it 0, 1? Oh, 0, 1, right? Because 1 is just a number. 0, 1 is a point, right? Well, if I know it's at 0, 1, what do I know also happens directly across the y-axis from that? Or, excuse me, the line of symmetry from that? Another point, because we know the axis of symmetry is a mirror. It's a mirror line. Okay? So then we know it also has a point at 2, 1. You okay with that? That's going to take a little getting used to. That's going to take a little practice. Okay? And I'm okay with that. We have time. Okay? And then if you want another point, because it's always nice to have another point, choose another value, plug it into the equation, or go to your calculadora, go to the table, and find another point. Plot it on your graph. Okay? How do you feel about this? Oh, and then draw it. Draw the parabola. Feeling okay about this? Okay, so we're going to stop today. I know that there's problems in that assignment that we have not covered yet. That's okay. I would like you to attempt the problems of the ones that we have covered. And then next time I see you, I'll teach you more and we'll cover the rest of the problems. Any questions? Any questions? All right. Have a good day. Peace. No, oh yeah, I forgot to press stop. Ah.